Chemical Reactions Unit, Lesson 3.4, What's in Westfield's Water? Activity 2, Identifying the Other Product. Looking at the atomic scale model from the warm-up, I see different atoms on the reactant side than I do on the product side. Is this possible? No. Why not? Because atoms cannot be destroyed during a chemical reaction. What does this tell me about the chemical reaction that formed the rust? It must have formed another product besides the rust. We have a new message from Dr. Jung. Dr. Jung is confirming the presence of another substance besides rust. Dr. Jung has observed the properties of the second substance and identified it as either sodium nitrate or potassium chromate. Based on your suggestions, I decided to run some more tests on the water sample I took from Westfield. As it turns out, you were right. The reaction between the iron pipes and the fertilizer seemed to have produced another substance besides the rust. I hadn't noticed it before because it dissolved in the water, but once I removed the substance from the solution, I was able to observe some of its properties. The unknown substance is a solid yellow powder at room temperature. It has no odor. Based on these observations, I was able to narrow down the list of possible substances to those that share all of these properties. I think the substance is either sodium nitrate or potassium chromate. I'd like you to determine which of these substances is the unknown substance in Westfield's water. I'm sending along an atomic scale model of each substance for you to use as evidence. Once you've identified the substance, be sure to inform the people of Westfield. These are atomic models of the two yellow powders mentioned in Dr. Jung's message. You will find them on your student screen. This diagram is similar to the one you examined during the warm-up. The key difference is that this diagram reflects the fact that we now know for certain that this chemical reaction formed another product besides the rust. This diagram shows me that reactants were made of iron, sodium, nitrogen, and oxygen atoms. This information is useful to me because, as we know from our key concepts, none of these atoms could have been destroyed or changed into other atoms during the chemical reaction. Students, choose what other substance could be in the water besides rust. A reaction between the fertilizer and the iron pipes could produce rust and sodium nitrate, but not potassium chromate. Which atoms were needed to form the sodium nitrate? Sodium, nitrogen, and oxygen. Were these atoms present in either of the reactants? Yes, they were present in the fertilizer. Which atoms were needed to form the potassium chromate? Potassium, chromium, and oxygen. Were these atoms present in either of the reactants? Oxygen was present, but potassium and chromium were not. Could the potassium and chromium atoms have been created during the reaction? No, atoms are never created during chemical reactions. End of activity.